Hello, Math 125 students. So today, or in this video, I would like to go over example 10 from lesson 1. Um, so this um, this lesson we'll be evaluating, or this example will be working out the limit of the following piecewise function given here. So recall a piecewise function is just another ordinary function that takes an input and then receives an output. But the only difference now is that when it ever receives an input, right, it will run the input against a certain condition, and depending on the desired condition, um, P of X, the input will run through a different function. For example, if I had P of 1, since X is equal to 1, P of X will take on the number 4. So that would be the answer, or that would be P of X evaluated at 1. Right? Another more interesting example is when if I have, say, P of 2, right? Well, since now running 2 into these two conditions, we realize that, well, it's obvious we can see that 2 is not equal to 1. So P of X in this case will take on the top function x squared plus 1. So we just throw the 2 into the top equation, or the top function, and we get 4 plus 1, and that's equal to 5. Right? So that's just a few examples and also a good review of what a piecewise function is, right? So when evaluating these kinds of limits, I would like to build a number line. And this number line will help me see, which side of X we are on depending on the context of the problem we're working with, right? So I have, right, in this problem, we're interested in evaluating the limit as X approaches 1, right? In this, given in these four parts, right? So on the left of 1, right? On the left, P of X would be X squared plus 1, right? Because anything on the left of 1 is not equal to 1, right? And then likewise, everything on the right of 1 is not equal to 1, therefore it would be X squared plus 1, right? So, and then at X equals 1, P of X is 4. So I'll just put a 4 on top, right? So if I ever need X to be equal to 1, then I will reference just this point. But it turns out actually in this problem, right? Since remember, because limits, we don't really care about what happens exactly at the point, right? So for parts A, B, and C, we can we all we can do, or not all we can do, but what we can do is we can eliminate this, or we can eliminate this 4, right? Because remember that the limits just care about what happens to the y values when x gets very, very close to 1, but not exactly at 1, right? So for part A, because remember, this is the left-hand limit. That means I'm coming from the left-hand side of 1, coming from the left. And everything on the left of 1 is not equal to 1. So therefore, the limit as x approaches a from the, or sorry, forgive me, x approaches 1 from the left of P of x is equal to the limit of x approaches 1 from the left of x squared plus 1. All right, now we boil this problem down into a limit involving a function of one variable, or one expression, my bad. Right. So now this is limit of a function with one expression. Right. So now, how do we evaluate a limit of this form? We just do a direct substitution. Just plug 1 into x squared plus 1, and then that will give you 2. So therefore, the limit is equal to 2. Now, similarly for the right-hand side, for the part B involving the right-hand limit, because there's a plus sign here, I'm coming from the left of 1, or from the right of 1. On the right of 1, I'm not equal to 1. So therefore, p of x will also take on this x squared plus 1 as I go from the right. And this is the same case. It's a function of one expression. So all we're going to do is just do a direct substitution, and we get 2. So the left-hand limit is 2, and the right-hand limit is 2. Therefore, part C, the limit exists, and it is 2. Right? And because the answer in part A is equal to the answer in part B. All right. Now this last part, well, the last part now we're just evaluating evaluating p of x at 1. Basically, what happens exactly at 1. Right? Actually, and turns out, right, because my input is 1 and x is equal to 1, or 1 is equal to 1, therefore I'll be taking on this expression. Therefore, your answer will be 4. And that is the end of this problem.